So now we are looking at another class still under the phylum Pseudomonadota, which is the class Epsilonproteobacteria. We'll look at the order Campylobacteriales, the family Campylobacteriaceae, and the genus Campylobacter. So Campylobacter gram-negative microaerophilic, motile with single polar flagellum, is oxidase positive, spirally curved bacteria, and non-fermentative, and adapts well to intestinal environment of poultry. So it's important in poultry, where the domestic and wild animals are reservoirs. Campylobacter causes gastroenteritis, usually by Campylobacter jejuni, and other species, for example Campylobacter fetus, causes bacteremia or blood infection in compromised hosts, or self-limited diarrhea in healthy individuals. We also have Campylobacter jejuni, incubation 2 to 5 days, where the illness lasts less than 1 week. So jejuni produces enterotoxin, similar to the stable toxin of E. coli, and a self-limiting diarrhea. So acute gastroenteritis with fever, cramping, abdominal pain, diarrhea, vomiting. It's more important in temperate countries. For diagnosis, it requires a microaerophilic and capnate condition to grow, and culture on blood agar plates. Optimum growth temperature is from 25 degrees Celsius to 42 degrees Celsius. You can obtain the sample either from the stool or blood. Treatment is available with macrolide type antibiotics. However, about 0.1% of the cases develop the Guillain-Barré syndrome, which is temporary paralysis, where you have autoimmune attack of the lipids of the nervous system. Next, we'll look at the family Helicobacteriaceae, the genus Helicobacter. So Helicobacter, the type species is Helicobacter pylori, spiral-shaped, multiple flagella, microaerophilic bacterium that is responsible for most cases of peptid ulcer disease, including gastric and duodenal ulcers. First cultured by Robin Warren and Barry Marshall in 1982, when they won the Nobel Prize in Medicine in 2005. Host factors are involved because not everyone who's infected will develop ulcers, only 15%, and many are infected, about 1/3 of the world population, but most show no symptoms. Other species are found in other animals. So Helicobacter pylori is able to grow in the highly acidic stomach by producing large amounts of highly efficient urease. So this enzyme will convert urea to ammonia and increase the pH surrounding the bacteria. So with these enzymes also, it is able to penetrate the mucus layer lining of the stomach. So the ammonium that is produced is toxic to the stomach lumen epithelial cells. Other enzymes, for example protease, catalase, and phospholipases, all cause cellular damage, which leads to peptic ulcer. So Helicobacter pylori is also designated as a carcinogenic bacterium, where gastric cancer develops in 3% of those infected. So you can see the Helicobacter pylori is able to neutralize the stomach acid, especially the environment surrounding the bacteria, and with its enzymes it is able to cause destruction of the mucus layer and when the mucus layer is thinned and destroyed, the gastric acid is able to destroy the epithelial cells and underlying tissue, causing serious ulcers. So here you can see the helical shaped Helicobacter pylori, and here is another diagram that shows the ammonia from the urease that neutralizes the hydrochloric acid and also causes ulceration and destruction of the stomach lining. So the production of urease, a vacuolating cytotoxin, and the CAC-A encoded protein which is associated with injury to the gastric epithelium, is encoded on the pathogenicity island that harbors 40 genes. So diagnosis is through tissue biopsy and culture of the organism. Breath tests for 13 carbon labeled urea is also available, and for children, tests for Helicobacter pylori antigens in stools. For treatment, we have Pepto-Bismol and the antibiotic metronidazole to remove the bacteria. However, now metronidazole resistant Helicobacter pylori strains have emerged.